So, around in '96, I made the connection of the breaking of the gene trait link, and everything kind of fell into place after that. I think a little bit after that, I read an interesting book that spoke about feedback loops, and the basic, the fundamental 80% of the model was sorted at that point, and hasn't really changed since, really. Although I've been still searching and trying to develop it and so on, but fundamentally, the model as I've described it was basically in place around 96. Then in 97, I was just continuing to look and develop some new stuff and so on. But I think around 98, I asked myself, how far can I push out this model? How far can it go to really expand to understand everything? So the next two lessons really relate to that. And I really like this aspect of the model. I find it very helpful and insightful and places things, in an interesting way. So, around 98, I kind of, from looking at everything, began to understand these three types of selection. So the first one is, I call it stability selection, which is responsible for that force is responsible for the development of the physical universe. And it has two aspects. One is the kind of the creative, random, if you want to think of it that way, or creative energy in matter, or matter is, or whatever way you want to think of it. But that sort of creativity, and then you have a selection process being applied to it, of selecting the most stable form. That it's always seeking to get more stable. And it's very intriguing, over time, things get more stable, which in itself actually can cause some more chaos. For example, when a star has run out of energy, it becomes more stable, or there's less resistance for its path if it kind of collapses in on itself, which ironically causes a huge explosion in the universe and a massive creation of energy. So you can see it's a really intriguing dynamic of what I refer to as stability selection. And it applies to all physical objects. And then the next one is natural selection, which I'm sure you're all familiar. Again, a kind of a random mutations, but they're not really quite random, because it's a selected process, more creative process that's refined and developed. And then along with that comes what we call natural selection, which I don't need to explain. And that's called natural selection. So that's basically that one, which obviously I certainly don't need to explain. And the next one then I call organizational selection, which again is two forces. One is human creativity, and the ability to be inspired and come up with new ideas and develop new ways of organizing ourselves and new tools and so on. And that then, the force of intelligent selection comes on as kind of looking at all these different possibilities for culture and technology, and applying our intelligence to figure out the best one to help us out in that particular situation. And that, of course, there's evolution in those. There's evolution in physical systems, there's evolution in natural systems, there's evolution in human systems, and human systems are the ones created by organizational selection. So it's interesting to look at it on that level of abstraction, and to see really there's just three types of selection, but each type of selection is very similar. There's a creative process and a selective process in each one, which is really cool. And then, I will speak a bit about it later on, because it's very important to get into the dynamics of health and illness and systems. I'll talk about it later on. But one thing that's interesting is this dynamic of health applies to all physical, natural, and human systems. And you say, what? The same dynamics apply across them all. And that's because they were all created through essentially the same forces, this kind of idea of selection. That's just, I don't think it really matters to the model or anything, but I do find it kind of cool to see these little patterns, So that's a kind of a cool one.